Sensors produce a signal relating to the quantity being measured. Example, a sensor transforms an input of displacement into a change in inductance. Transducers, on the other hand, transform the energy of the process variable to an output of some other type to operate some control device. The various specifications of a sensor transducer system. Range. Range is the limits between which the input vary. Example, a thermocouple for the measurement of temperature might have a range of 25 to 225 degrees Celsius. Span. By span, we mean the difference between the maximum and the minimum values of the input. Thus, the above mentioned thermocouple will have a span of 200 degrees Celsius. Error. Error is the difference between the result of the measurement and the true value. A displacement reading of 29.8 mm when the actual displacement is 30 mm has an error of minus 0.2 mm. Accuracy defines the closeness of the actual measurement to the true value. It's expressed as a percentage of the full range output or full scale deflection. Sensitivity. The ratio of change in output per unit change in the input value that causes the output changes is sensitivity. For example, a general purpose thermocouple may have a sensitivity of 41 microvolts per degree Celsius. Resolution. The smallest detectable incremental change of input parameter that can be detected in the output signal. For example, if a LVDT sensor measures a displacement up to 20 mm and it provides an output as a number between 1 and 100, then the resolution of the sensor device is 0.2 mm. Stability. It is the ability to give the same output when measuring a constant input over a period of time. The term drift indicates the change in the output that occurs over a period of time. It is expressed as the percentage of full range output. Precision. It's the ability of a sensor to give the same output for repeated applications of the same input. It's expressed as a percentage of the full range output. Now, pass for a reflection question. Two thermocouples A and B measure temperatures of two liquids with values having error range of 0.2 degree and 0.3 degrees respectively over a number of readings. Which thermocouple has more precision? Answer. It should be remembered precision is expressed as a percentage of the full range output. Since range is not specified, the precision could not be obtained in percentage. Hence, the best precision of the two cannot be determined. Next, hysteresis. The maximum difference in output of any measurement value when approaching the point first with increasing and then with decreasing the input parameter is called hysteresis. It can occur during measurement of temperature using a thermocouple. Non-linearity. The maximum deviation of the actual measured curve from the ideal curve is called non-linearity. It is equal to the maximum deviation in input divided by the maximum full-scale input. It depends upon the environmental factors including temperature, vibration, acoustic noise level, and humidity. It is important to know under what conditions the specification is valid. And next, classification of transducers. Broadly classified into active transducer, which is a self-generating and develop their own voltage and current. Example, thermocouple, piezoelectrics, photovoltaic cells, etc. Passive transducers, they are externally powered transducers, derive the power required for energy conversion from an external power source. Example, potentiometric devices, differential transformer, resistance thermometer. Classification of sensors. Displacement sensor, basically used for the measurement of movement of an object. Position sensor are employed to determine the position of an object in relation to some reference point. Proximity sensors are a type of position sensor and are used to trace when an object has moved within a particular critical distance of a transducer. Thank you.